This example is a little bit different from the others that we have been asked to graph. We're asked to use the 5-step method to graph the following polynomial. However, notice that my polynomial is already in factored form. Go ahead and put any understood exponents that you have on the factors. So in other words, here we'd have an understood exponent of 1, and here another understood exponent of 1. That will help us with the very first part of my 5-step approach, and that is to determine the end behavior. Remember here that if you have a polynomial, I'm going to say not in the correct format. Polynomials means a sum or difference of terms. Here we have all the factors. So if you have something not in the correct form and you're trying to determine the end behavior, your degree is always going to equal the sum of the powers. So sum of powers on the factors, otherwise known as the sum of the multiplicities. And so on here, we would have a power of 1, a power of 2, and another power of 1, so that's power of 4. So basically here we know that our x would end up being raised to an even power of 4. Now we need to know if the value in front of our leading term would be negative or positive. We'll look in front and see what type of value you have in the front. We see here it's a negative. So the leading term, whatever the leading term is, would have a negative value in the front. So the end behavior of this would be an even function, which means the ends would go the same way, but it's a negative even function, which means that both ends are going to go down. So there's our end behavior. Second step of this is to find the maximum number of zeros and the maximum number of turning points. Maximum number of zeros is always the same as the degree of the function. We said that the degree of the function had to be 4. So that's the maximum number of zeros. The maximum number of turning points would always be 1 less than that value, and so here it would be 3. Step 3 is to find the y-intercept. The y-intercept is found by letting x be 0 and then evaluating my function at x is 0. So f of 0 would equal negative 1/2 times 0 plus 3 times 0 minus 1 squared times 0 plus 2. The negative 1/2 stays in the front. 0 plus 3 is just 3. 0 minus 1 is negative 1, but then when I square it, it would become positive 1. And then 0 plus 2 is just 2. Now here, since I'm multiplying these 4 values, I can actually cross-reduce if I see anything that would do such. We notice the 2 here could cancel the 2 there, and so I'm left with negative 1 times 3 times 1, which would be negative 3. The y-intercept always needs to be written as an ordered pair. I plugged in 0, I got out negative 3. So 0, negative 3 as my y-intercept. As the fourth step, I need to find my zeros, or my x-intercepts. To do that, I would need to substitute 0 for f of x into my original function, and then I'm wanting to solve for x. I believe this function is actually called g of x, but in this case I will substitute the 0 in as usual. And then here it was negative 1/2, and then x plus 3, and then x minus 1 to the second, and then x plus 2. I want to find the zeros, which means I need to factor. Well, it's already factored. Because it's in factored form, it makes it very easy to determine the zeros and also their multiplicities. So on here, if I have x plus 3 as a factor, then I would automatically have a 0 of x equals negative 3. Its multiplicity, we can see, is 1, which would mean the graph would go right through that value. Here we would have x equals positive 1. Its multiplicity is 2, which means we would turn at that value. And then over here we would have x is negative 2. Its multiplicity is 1, which would mean that we go through that value. Take these zeros and write them as x-intercepts. So we would have the x-intercept of negative 3, 0, positive 1, 0, and negative 2, 0. Go ahead and box these in. We're going to want to graph these here in a bit. All right, moving on to the last step, and that is to graph. We're going to first graph any and all points that we have found. Scrolling back up, the y-intercept was 0, negative 3. So I'm going to go down 1, 2, 3. There's that point. We have 3 different x-intercepts. Now notice, at the front of this problem, we said that the maximum number of zeros that we could have is 4. We actually ended up with 3 zeros. That's a fine thing to have happen. So we have negative 3, 0. We have 1, 0. And we have negative 2, 0. Now look back at the end behavior. Okay, based on what we knew about the degree and then the sign of what would be in front of the leading term, we determined that the ends both pointed down. So that being the case, I'd have to have my graph starting here, coming up, and then on this side, the similar idea, but going down. And then look what we know about the zeros. Negative 3, 0, we know we have to go right through that 0. So we're going to have to go up and through that one. At negative 2, 0, we have to go through it as well. Notice that somewhere above or between these two zeros, we'd have to hit a maximum and come back down. We don't know where that value is, but we know that that would have to happen. And then finally, at the 0 of 1, 0, we'd have to turn. So this graph will have to turn at that point. Now, we know we have a maximum somewhere up here. We know we have a minimum somewhere here or here, but we don't know which side. So let's use the calculator to find those 3 values. So we want to go back up, and into y1 we're going to enter in our original function. So negative 1 divide by 2, and then parentheses, x plus 3, close parentheses, open parentheses, x minus 1, close parentheses, raised to the second, and then open parentheses, x plus 2, and then close parentheses. So type it in exactly as it's written. Go ahead and let's do zoom standard, see if this will work. If it won't, we can adjust it. It looks like that works just fine. We see that we have a maximum value here, and it looks like our minimum value occurs just to the left of the y-axis. Okay, let's go find those 2 values. Second trace, let's do the maximum first. We want to go to the left of the maximum value. Press enter. Go to the right. Press enter. When it asks for a guess, press enter again. Okay, let's round to 1 decimal place. So the maximum value that we are finding here is negative 2.6 and 1.6. And then it looks like our graph turns, comes through the y-intercept, hits the minimum somewhere down here to the left. Let's go find that minimum. So second trace, minimum this time. We want to go to the left of our minimum value, so somewhere in here, press enter. Go to the right, press enter, and then when it asks for a guess, press enter again. And let's round to 1 decimal place as we did before. So negative looks like 0.7 and negative 4.3. Okay, let's go ahead and label those other points as well. We had an x-intercept of 1, 0. We had a y-intercept of 0, negative 3. We had another x-intercept, negative 2, 0. And the last intercept, negative 3, 0. So we have each of those labeled. Notice that we have a relative max here. We also had a relative max there, but it was a 0 and it was a place where my graph turned around, so I didn't have to use my calculator to find that. I have a relative min here.